Hello everyone, I'm going to talk about the job schedule, this system design problem. So what is the job schedule? The job schedule is a program that automatically schedule and execute jobs at specific time or intervals. It is used to automate repetitive tasks, run schedule, maintains, or execute batch process. So it's kind of like it's very often used in the CI/CD like automations. It's very similar design. So let's see. But first, I want to clarify the difference about the task and the job. A task is abstract concept of work to be done. For example, send an email, no too much detail. Tasks are reused and can execute multiple times by different jobs. It's more big. And for the job, a job is an instance of task. It's made of the task to be executed, the schedule for when the task should be executed, and parameters need to execute the task. For example, if the task is send an email, then a job could be send an email to John at example.com at 10 a.m. Friday. It's very clear and kind of like AI or know how to do that. Yep. So we start from the requirements here. There has function requirements. The users can schedule jobs for the future or immediate execute. Users can query for their job status. So for the scale, we can like 10,000 jobs seconds execute. So it's very large. And for the non-function requirements, availability is larger than the consistency. Execute job within 2 seconds of their scheduled time. Scaled to support up to the 10K jobs per second. Execute at least one execution of job. Yeah, so for this one, we have some very important entities. Entity is kind of like a matching for the database tables. So I need the users information and the jobs information and also task, right? And also schedule table. So this is a very basic information. And for the API, we have API is matching for the function requirement. The first we can fetching for the created job. So post some details like task ID, schedule time, parameters, and to somewhere and subject. It's kind of like sending the email. And also for the second one is can query the job. It's called like get status. Query for their job status. Yeah. So this is matching for the function requirements, first one and second one. And also for the data flow is user schedule. You can see user schedule a job and persistent the job in the database, and the job job can pick up and execute at the schedule time. We have the time, and if fail, just retrieve, right, or just return back and update the job status in the system. So it's kind of like data flow. Now we start in the high-level design. So high-level design, we have the users and also job, task, schedule, right? Schedule, service, and database to store something. And task is task SQL. So the API is kind of like client sending the create job. Then it will go to the schedule service and then create it and store enough information in the database. And then also the task queue, right? So it's we're calling for our current now job created, you have to do something. And also store the status back to the database. So we have to create the table SQL jobs to store some very important information like use current job, who did this, and what's the task ID, right? And for the parameter and some time for the schedule, you can see we have the execution, we have the job user status. So this is something happens and return back. This is more detail about the jobs table status for the definitions. We have the job ID, like for example, user ID, who is the, this one task ID, I will treat it like tag, right? Sending the email. And sending the email, you have different step. So schedule something here, parameter. So for the execution table is which one, time, job ID, user, what the state is finished, if something happens. Yeah, it is the bucket run down to the near hours. So this is some information about the database. So this is a high level design here. Now we come into the deep dives. For the clients here, we first one, available and the larger than the consist, which means for the availability, we have to make sure availability is here. So when the data, right, SQL, this is a huge execution service, but task execution service, but separates into more detail. So this is the when the right SQL job, when something happens, bad thing happens, how could I do? We can just retry it, right? So if current SQL job just fail, and then we can program it, like retry it in the later 5 seconds, go back to the kind of like rerun it. So, but also in order, right? So just and also we can trying to logic it here to set that how many times it can retry it. We can suppose just one time, then put it back. And also to mention the work ID, which one, which worker fall down. Maybe this here have a lot of workers, not just one, because this is based on the microservice architecture. This is one solution, but this solution might be not the best because it will trigger like if there are so many workers, did I every time need to call these functions over and over again? So it will trigger another problem. So it's kind of like not the best way. So we can use based on the SQS. So this is kind of like a cloud servers, Amazon servers. They offer the information to check current work whether it's shut down or not. So it's kind of like a built-in function. You can work it. This is already have a more professional people focus on help you to do this thing. You can just take care to use it. And also they might handle the current here what fair, whether it's the large of the too much get question something. You don't need to worry about that. So you can use this way. And if not use that, we also can use like distribute locker, right, to do that. And Zoom Keeper or something to keep checking for the SQL job. So this is for the availability and consistent. Okay, so what is for the second one is to scalable to support about 10K jobs per second. So originally we just have one schedule service, right? So it's kind of like all the requests you have to send it request to this service. So for this one, we can separate it. This is go to the query service, and this one is going to the created service. Okay, this one. Created service. So it's kind of like separate the different requests to the different servers. And also we have the gateway inside. We also can do some rate limits. Also can help to the scale to support 10K jobs per second. So this is the way to do this. And the second one is escalate the job within 2 seconds of their SQL time. Okay, so for this one, we can do is just use worker, improve a lot of worker, right? And to do, we can do this. We can separate original this task escalator. We can separate in different step, like watcher, right? To separate and use the message queue to schedule based on their time, to schedule the running time. So this is a good way to use that. Yeah, but you can set up do some configuration of current message queue. It can delay until execution time. You can configure that to do that. So that is the way to do that. And for the ensure at least one execution job. So this problem is more like programming. You have to set up the logic during the writing the code, not for the high level schedule specific service queue. So you also can use the database, right? You can design the job to naturally ideal moment by using this one. Just make sure it's kind of like not duplicate the purpose for here and conditional operations. Like instead of increment counter, the job will be the set counter to X. It's more exactly. Instead of setting welcome email, we first check it if the welcome email flag is already set in the user's file, right? So each job SQL include a unique identifier that downstream service can use it to duplicate the requires. So when we send in the job, also we can treat like the job like a current job ID, whether it's unique, right? We can based on the database schema, we can make sure that job ID or SQL ID is already just only have one, and also sending this to make sure the global is unique. That also is a good way to make sure not duplicate and just at least the execution just one time. And also we have we also can create another table to track our current executions, current job, whether it's run it, whether or not. So that is more focused on the schema design. Yeah, this is this problem, and thank you.